Good morning. Thank you all for being here. It's crazy to see that there's more people than seats, which, no pressure, but I'm going to do my best. We only have 25 minutes and a lot to talk about, so I'm going to kick right off. I want to introduce myself very quickly. My name is Sanne Kalkman. I live close to here in Amsterdam, and I'm a senior software engineer at Code Sandbox. Some of you might have heard about, who has heard of Code Sandbox? Oh, that's a few people. That's nice. Yeah, we're a cloud development environment. We spin up VMs really quickly, and you can collaborate really easily. I kind of stumbled into Elixir by accident. My first job out of boot camp happened to be an Elixir team, and I haven't done anything since, and I don't want to do anything else, which is why, and I'm going to tell you why today. Other than that, I love crafting, and I love my two cats. This is one of my cats. This is his baby photo. So I always put him in because it's just so cute. If you want to reach me, I'll be around all day, or you can find me on Twitter at Sanne Kalkman. All right, Elixir. The idea for this talk came to me when I read the Stack Overflow survey of last year. It said that 73% of the developers who have used Elixir in the past year want to use it again, meaning Elixir comes second only after Rust. And when it comes to development frameworks like web frameworks, Phoenix, the go-to framework for Elixir, is by far the highest scoring, 82%, followed by, I think Svelte was second with 75 or something. So if you use Elixir, you'll probably love it. But on the other hand, only less than 5% of developers said that they have used Elixir in the past year. So that's kind of the point of this talk, is to bridge that gap. This is for that 95% of you who have never considered using Elixir before. And hopefully this talk will give you a little bit of an idea why I love it, why people who use it love it, and what makes it a good choice in at least some circumstances. So we're going to go over a few things, and they're all going to be quite brief. We're going to start with, I don't want to end with the negative, so I'm going to start with the negative. Why would you not want to use Elixir? When we get that out of the way, we're going to talk about where the magic really happens, which is in the beam, that is the Erlang Elixir VM. And then I want to talk a little bit about Phoenix, the web framework, and specifically Phoenix Live View, and how we use Elixir and Phoenix at Code Sandbox. So let's dive right in. The 4 main reasons I hear for not using Elixir, and they're all valid, are these. Elixir is slow. Erlang is slow. If you compare it to Rust or raw C or whatever, yeah, sure, it's slow. But in most cases, it's fast enough, right? If you need that much speed, then yeah, maybe Elixir and Erlang are not the right choice. The ecosystem is small. Again, if you compare it to Ruby, JavaScript, etc., the sheer number of packages and libraries available, it's less. You have to roll a little bit more by hand sometimes, but it is growing, and as adoption grows, the ecosystem grows as well. It's too difficult a language. Only seniors can learn it. We can't possibly hire juniors if we use Elixir. A few years ago, I actually gave a whole keynote at an Elixir conference just about this, because I disagree. I was a junior. I was fresh out of boot camp. I learned Elixir, and yeah, was it different from Java or whatever? Did I have to get rid of whatever OOP I learned during boot camp and swap it out for a more functional way of thinking? Sure, but once I got there, it was fine. And related to that, people say it's hard to find developers because it's a small language, there's not that many developers. But if you solve step 3, you solve step 4. If you hire juniors and train them up, guess what? You'll have more developers. Of course, there's more to it, but in principle, I think if a company is willing and a team is willing, you can train people up. So this is why you wouldn't maybe use Elixir. But let's move on to why you would. And to start with, I want to show you, I only have time to dive into one. I want to show you one of my favorite language features. And I made the mistake that I want to live code, but I have a handheld mic, so we're going to see how that goes. All right, I want to show you a little bit about pattern matching. So I'm going to see if I can switch to the Elixir shell. There we go. Luckily, I pre-typed everything, so I'm just going to copy-paste. There we go. So let's say you do something like this. You have a cat. You have a tuple. The first value is cat. Second is parm. The thing that starts with a colon is an atom, which is used for constants. That's all you need to know about it right now. So far, so good, right? Looks like variable assignment. But in Elixir, the equal sign isn't really assignment. It's called the match operator. And what it does is it kind of asserts that the left side is not equal, but like can be destructured compared to the right side. So I can do something like this. 1 is 1. Like, it's not assignment because I can't assign 1 to 1. Another thing I can do is I can use it to destructure. So you can say animal, name, and then if I just want animal, I just get cat, and name would be parm. But where this is really cool is that you can use constants in your matches to assert certain things have the right value. So, for example, if I do this, I say, okay, on the left side I have what I want to match, which is cat, and then I want to pull out the name. But my right side value is, in fact, a dog with the name Kiba. Unsurprisingly, Elixir doesn't like that. And while this may not look amazing at a first glance, it allows you to do a lot of cool things, especially in function definitions. So imagine a function like this. It's a function called meow, and it takes some sort of tuple. In some other languages, you might have to say, if the first value is cat, return this. If the first value is dog, do this, etc. But in Elixir, you can just write multiple function heads that do this matching directly in the arguments. So if I input something that starts with the atom cat, I'll say name says meow. If it's a dog, then I'll say dogs can't meow. The underscore means I know this is a value, but I don't care about it, and I'm not going to use it. And then the last one, if it gets anything else, it says, well, I don't know what you're trying to do. So this would be the expected output here. There's a lot of stuff that makes Elixir really nice and readable, but this is one of my favorites. This is the one that I miss the most if I have to write anything else. But we're moving on quite quickly to a much lower level. We're diving deeper down into the Beam, which is the Erlang Virtual Machine, because Elixir and Erlang share a runtime, and lots of other languages do. Whenever I say Elixir in this case, it applies to Erlang, it applies to any language that runs on the Beam. Beam and OTP, they're abbreviations. They stand for things, but nobody really cares anymore. I think it's Bogdan's Erlang Abstract Machine and Open Telecom Platform, but you don't need to know that, and there will not be a quiz at the end. So the core thing about Erlang and Elixir is processes. Those are the building blocks that are at the root of everything. Everything is a process. And the cool thing about processes, and a process in this context, it's not like an operating system process or a thread or whatever. They are really, really lightweight. An Erlang application has thousands, even millions of processes running at the same time, each doing their own thing. They're really lightweight. They're also isolated. Each process has its own like memory, its own stack, its own heap. It gets garbage collected separately. They're really, really isolated. They don't know anything about each other. The only way they can communicate is by sending each other messages. So each process has a little mailbox. Process A sends a message to process B. It gets handled. It does something, and it either sends a message back, or it doesn't, or whatever. The concept behind it is often referred to as the actor model. I think a little bit later at 12:30 on stage 3, somebody has a talk about concurrency models, and I believe they will talk about the actor model maybe in a little bit more detail than I have time for right now. So that is the basic building blocks. You can spawn a function, spawn a process, have it go back, etc. So one of the things, often quoted things about Erlang and Elixir is the philosophy of let it crash. This is not a thing that you generally want in most languages. But the idea is kind of that you don't, if you have good resiliency in place, you don't really need to worry about one of these thousands of processes failing and erroring out, because all the others will continue. And you can have self-healing, hopefully, in most cases, in place to keep it going. And this is where OTP comes in. OTP is a set of building blocks on top of this basic idea of a process, and it's like a library on top of it, giving you a way of thinking and an easy way of implementing these resilient systems. The basic idea is that the processes kind of get divided into two types. You have the workers, which unsurprisingly are the ones that, do the work. And then you have supervisors. And supervisors are processes and their job is to monitor, to start, stop, and monitor workers or other supervisors. And if you arrange these together in some sort of a hierarchy, you end up with a supervision tree. And that is what almost all Elixir and Erlang applications look like. It starts with a top-level supervisor, which starts, some more supervisors for different parts of your application or different sub-applications. You can almost think of it as if your application was a lot of kind of connected microservices, each supervisor could represent a microservice. And those can then spin up workers as needed or long-running ones. And this is cool because this allows you to isolate failure. If in this structure, if something goes wrong in worker 1 or 2, the whole other side of the tree, they won't even notice. They're just going to keep doing their thing. And the cool thing about the supervisors is that if something goes wrong, a worker dies, or any process dies, it gets restarted. I mean, I'm sure you're all familiar with the ongoing joke from the IT crowd, right? Have you tried turning it off and on again? That's basically what it is. A lot of crashes occur because of bad state. And if you restart, you start fresh. And that is the whole principle behind OTP and behind these supervision trees. You can just, if something goes wrong, you just restart and it'll probably be fine. Now, of course, if something is really, really, really wrong and one process restarts a lot of times, it'll go one level up the tree. And then the next one, we'll just go okay, we'll go one level up the tree, we'll restart everything below it, see if that helps. And if that doesn't help, then eventually, yes, it'll go all the way up and your whole application will crash. But that has only happened once in my career, and that was because of a really, really dumb mistake. Another cool thing about this process structure is that you can isolate slowness. You can have one process that's doing a long-running, computationally heavy job, and you can have a bunch of others that are doing all the other things, and they're not blocking. How this works, it's not necessarily the case that the long-running one takes up all the time and a whole core. The Erlang scheduler kind of it gives each process a little bit of time, and then it goes to another one, and another one, and another one. So everything still kind of happens while the long-running process is going. Yeah. So that is that was a very, very whirlwind view of OTP. At the end, I have some resources if you want to learn more, because this is, 10 minutes barely scratches the surface. But I do want to have a little bit of time to talk about Phoenix as well. This kind of jumps us from almost the lowest level of abstraction to perhaps the highest level of abstraction that an Elixir developer will deal with. Phoenix is the easiest way to explain it. It's to Elixir what Rails is to Ruby, what Django is to Python. It's a framework for web applications that gets you up and running. It gives you routes, controllers, views, etc. But the part that I want to highlight that is really cool is Phoenix Live View. For some of us, this is a big selling point. It allows you to write interactive applications with basically no JavaScript. Basically only Elixir, because almost everything happens on the server. And we just talked about processes. The way to think about it is each live view is a process. Each person looking at a page gets their own process. That process receives a message. This can be anything. It can be user input. It can be hitting a submit button. But it can also be a message coming from another process. The live view does something. It submits the form. It saves something to the database. It updates a state. And then only the changed portions of the page get re-rendered. And I'm sure other libraries and frameworks, they all have smart change tracking and all that kind of stuff. Live view, it goes all over WebSockets. It's server-side rendered, and it has really good change tracking, so only the minimal difference, no full HTML after the first page, so only the minimal difference of the actually changed portions of the page gets sent over the wire and get re-rendered. And that's really cool. And this is one of the things that has brought us a lot of cool stuff at Code Sandbox. Because we use Phoenix, the main Phoenix, as our whole backend API server. We have only 2 developers with about 1 million requests per hour, roughly. And, it's all going along, nowhere near capacity. And that's cool. I think it's cool that only 2 people can maintain an application that has, only the backend. We have more folks on the front end, of course. But yeah, just with 2 of us, we can maintain the whole backend application. But live view has really been a jump for us in productivity. And I want to give you 2 little examples of this. First of all, we're a small team. We get emails. Can I change my email address? Oh, I bought a subscription, but it's not working, et cetera, et cetera, et cetera. And for the longest time, all these emails would get passed on to me and my coworker because we were the only ones who could, directly SSH into production to look into the database to figure out what was going on. Don't do that. It's not a good idea. But it was taking up a lot of our time. So the first thing we ended up using LiveView for was to build a support portal, just internally. It serves on a separate endpoint, but it has access to all the same core functions that we use for our actual business logic. But it has separate logins. It has full auditing of who looks up what, etc. But it really, really reduced the support load. Getting it off the ground was a little bit of work, but now it's there. It's so much easier because both, it allows the sales people to start trials or to, activate feature flags without us having to do any of that. And so that has really, really helped. But this is internally. None of you will see this. But recently, we've also actually added a little bit of live view to our otherwise totally React front end. If you've ever worked on any sort of application that has teams and subscriptions, etc., managing the subscriptions and stuff can get quite hairy. Member permissions, subscription details, billing details, blah, blah, blah. And we were running into trouble where the React version of this management, the GraphQL mutations were getting out of hand. And we weren't flexible because, once you have a field in GraphQL, you can't just get rid of it willy-nilly. But on the bright side, these settings could be changed from anywhere. If we were we want people to change their, team members' permission right from the editor, they could do that. So that was a benefit. But in switching to live view allowed us to move much faster because at this first step, we could basically cut out writing the API contract because it was all directly into Elixir and we could directly call the Elixir functions that we would have called, but we could cut out, the having to write a mutation, figure out the fields, and et cetera, et cetera, et cetera. It also allowed for better performance control on our end, especially for complex data and queries, because you know how in GraphQL, if you're not smart about loading and you query too many nested fields, it can get out of hand. One of the things, for example, we wanted to show is all the sessions for all your running VMs throughout history. You can query those, to see where your money is going. But as you can imagine, that can get really big really quickly. So doing this in live view allowed us to have full control over how we load it and the performance there. This lack of API contract allowed for much faster iteration because we're a startup. We're still trying to figure out how to make money, right? So things change. So like, oh, we want people to pay for this. And then like, oh no, actually maybe that should be free. Maybe they should pay for that instead. And having that kind of like billing management in so tightly coupled to the business logic made it much easier for us to iterate on that. And then we also just had one place for everything, which is, a benefit and a drawback. It's easy to send people to one URL because that's where all the settings live. But sometimes you want to change things elsewhere. So what we did, after some iteration, the features that we decided on that they were stable, those were the ones that we then ended up making mutations for, so you could also do them from other places. For example, you can choose the specs for how beefy a VM you need for your project. Initially, you could only do that via this workspace management page. But now we've ironed out how that works. We've exposed the API, and you can change it directly in the editor. But having that extra step has really helped us move faster. So yeah, that is, in short, that is a very, very whirlwind overview of Elixir and what I like about it and why I encourage all of you to give it a try. Since, again, there's only so much I can say in 20-25 minutes, I have some resources for you if you are interested and if you want to learn more. First of all is a talk by Sasha Juric called The Soul of Erlang and Elixir. It's a 45-minute talk, and it really goes into this, like the magic of these processes and the concurrency on the beam. Then there is a book also by Sasha Juric called Elixir in Action. This is basically the book if you want to learn Elixir, especially if you already have experience in a different language. Pick up this book. It's been out, a new edition just came out. If you specifically want to dive into live view, the book Programming Phoenix Live View by Bruce Tate and Sophie De Benedetto is a good one. The documentation, elixirlang.org. I think it's phoenixframework.org, I'm not sure. And if you're more interested in the Erlang side, if you want a taste of history, go on YouTube and have a look at Erlang the movie. It won't really teach you anything, but it'll be fun. Oh, it'll teach you something about, the origins of Erlang. And lastly, also a book available freely online is Learn You Some Erlang by Fred Hebert. If you have any questions, I'll be around if you want to chat about Elixir, Erlang, cats, knitting, whatever. And thank you very much.